This may not be the best deep learning framework, but it is a deep learning framework. Due to its extreme simplicity, it aims to be the easiest framework to add new accelerators to, with support for both inference and training. If XLA is CISC, tinygrad is RISC. Tinygrad is still alpha software, but we raised some money to make it good. Someday we will tape out chips. Features: LaME and Stable Diffusion. Tinygrad can run LaME and Stable Diffusion. Laziness. Try a matmul. See how, despite the style, it is fused into one kernel with the power of laziness. dig equals 3 pay python 3 dice c from tinygrad import tensor n equals 1024 a b equals tensor.rand and nn c equals a.reshape a b reshape 1n dot sum axis equals 2 print c dot numpy a numpy at mean, and we can change debug to 4 to see the generated code. Neural networks. As it turns out, 90% of what you need for neural networks are a decent autograd tensor library. Throw in an optimizer, a data loader, and some compute, and you have all you need. From tinygrad, import tensor, nn class linearnet, def init self.l1 equals a tensor.chiming uniform 784 128, self.l2 is tensor.chiming uniform 12810. Def call self x tensor, return x.flatten1, self.l1, relu.l2, model equals linearnet, optim equals n and optim.atom, model m on model 2, lr.001, xy x tensor.rand 4, 1, 2828 tensor 243s.train, for I in range 10, optim.0grad, loss equals model x, sparse categorical cross entropy y backward, optim.step, print I, loss.item. See examples beautiful mnis.ppy for the full version that gets 98% in 5 seconds. Accelerators. Tinygrad already supports numerous accelerators including GPU, OpenCL, Clang, C-Code, LLVM, Metal, CUDA, AMD, NV. Installation. The current recommended way to install tinygrad is from source. From source git clone http://github.com/tinygrad/tinygrad.git cd tinygrad python 3-m pip install-z. Direct mast python 3-m pip install git github.com/tinygrad tinygrad.git. Documentation. Documentation along with a quick start guide can be found on the docs website built from the docs/directory. Contributing. There has been a lot of interest in tinygrad lately. Following these guidelines will help your PR get accepted. We'll start with what will get your PR closed with a pointer to this section. No code golf. While low line count is a guiding light of this project, anything that remotely looks like code golf will be closed. The true goal is reducing complexity and increasing readability, and deleting S does nothing to help with that. All docs and whitespace changes will be closed unless you are a well-known contributor. The people writing the docs should be those who know the code base the absolute best. People who have not demonstrated that shouldn't be messing with docs. Whitespace changes are both useless and carry a risk of introducing bugs. Anything you claim is a speed-up must be benchmarked. In general, the goal is simplicity, so even if your PR makes things marginally faster, you have to consider the trade-off with maintainability and readability. In general, the code outside the core tinygrad folder is not well tested, so unless the current code there is broken, you shouldn't be changing it. If your PR looks complex, is a big diff, or adds lots of lines, it won't be reviewed or merged. Consider breaking it up into smaller PRs that are individually clear wins. Running tests, you should install the pre-commit hooks with pre-commit install. This will run the linter, mypy, and a subset of the tests on every commit. For more examples on how to run the full test suite, please refer to the CI workflow. Some examples of running tests locally: Python 3-m pip install -c testing. Install extra deps for testing. Python 3 test ops.py, just the ops tests. Python 3-m pytest test/whole test suite. Process replay tests. Process replay compares your PR's generated kernels against master. If your PR